Oh, welcome everyone. Oh, brilliant. Okay, that's kind of like that's still the Wednesday afternoon bit. This session, I love this session. This is, as you can see from the title here, Touch Me, Stretch Me, Squeeze Me, the Windows 7 WPF multi-touch story. In the interests of truth and honesty here, I'm not going to touch anyone at all. And I'm truly hoping you're not going to come and touch me either. If anyone comes towards the stage, I do have some mace here that you are welcome to have dispensed at you. It's not that kind of a session. It is about using multi-touch, which I am very happy about. I love this subject. My experience of multi-touch started 3 years ago at Microsoft UK, when they were showing Microsoft Surface 1. It's a table device, and it's multi-touch, and it's all kinds of things other than multi-touch. But it was beautiful. I thought, this is it. This is the answer. I have been truly unimpressed with the technology that we've had up until that point. See, we have, I'm not going to disconnect them, but we have keyboards and mice. And you go, that's a terrible solution to the problem. The problem is that we need to interact with computers, and in the 1980s, people thought that keyboards and mice were a really clever idea. And they also thought that digital watches were a really clever idea at the time. That kind of shows you how clever that industry was at the time. And that was great for 1980 with the technology that we had at the time. It's 30 years later. We moved on. Surely we moved on in that time. And the problem that I have with keyboards and mice is if you're going to write a document for your company, or you're going to write a book or something like that, you need a keyboard. That's fine. I'm okay with that. But if you think about the computing devices that we have in the world today, there are many devices. They're just everywhere. They're on your pockets. They're in your house. They're in your car. All the computing devices, they're just pretty much everywhere, with a couple of exceptions. And two notable exceptions which just don't make much sense here are your living room and your kitchen. So in your living room, you have a games console. There's some kind of games console in there, but you're not using it as a computer. You're using it as a games console. You don't have I'll bet you probably don't have a computer inside your living room. You don't have one inside your kitchen. Now, there are reasons for that. The reason why it's not in your living room is because computers are ugly. They're just really ugly devices. You don't want them in your living room. The other reason, and what goes along with that, is a keyboard and a mouse. You take your keyboard and mouse and you put them in your living room, and they just look wrong. It's all computing stuff. That's not what we want in the living room. They're not in your kitchen because the moment you take your mouse and you slide it across the surface and it goes across the peanut butter and the jam and your toast, and then you take your keyboard. How long will your keyboard last in your kitchen? How long before someone goes, oh, there's some milk on my keyboard, bye-bye keyboard? These devices don't last in a kitchen. They'll be trashed within a week. So that's the wrong device for a kitchen. Now, if you free yourself from those physical devices, you go, let's use something else that is suitable for both those environments, and I'm talking about touch here. If you free yourself from that, what applications could you write which have not been written yet? And I'm saying that's happening in 3 years. Within 3 years, your kitchen and your living room will have applications which haven't been written yet and which will revolutionize our worlds. Why I like multi-touch is because if you do it now, then you have a jump on everybody else. You have the next killer app. That's what I want to show you in the next hour and 10 minutes. Everyone okay with the plan? Hey, that's me and the person over there. Good. So, who am I? I'm Guy Smith-Ferrier. There's my Twitter tag. That's it. Clearly, I'm not from round here. I've got that funny accent. That I assure you I'm not talking like this for a bet. I actually do talk like this all the time. So here's what we're going to do in the next hour and 10 minutes. I'm going to go through Microsoft's concept of good, better, and best. We'll see what that means and why those are a good way of categorizing touch in applications. We will talk about what do you need to get started. in developing multi-touch applications. We'll talk about the manipulation API. This is a high-level API which has got a ton of engineering in it and a ton of power to make your life really easy. We'll see how that works, and you'll see this stuff is very clever. We'll then look at the raw touch API, which is a low-level API. This is one of those Spider-Man APIs that you get in the .NET framework, where with great power comes great responsibility. So it's a low-level API, and we'll see that. We'll see lots of examples of doing that. We will look at the Surface Toolkit for Windows Touch. The main thing you need to know about the Surface Toolkit for Windows Touch is it is not specific to Surface. I don't have a Surface device here. I have a multi-touch laptop. It's the same toolkit for WPF, which is what I'm doing all my demos in, as it is for Surface. So if you're thinking, I'm not going to do this with a Surface device, that's great. It's still relevant. That's what we're going to do. So let's look at these concepts of good, better, and best. So Microsoft categorizes applications into these different areas. I can't believe that this is Calc, okay, and I'm using Calc as an example of good, which is a bizarre kind of idea. But we can see here, if I just flick the screen to the right place, which is actually, nope. Okay, let's flick the screen to the right place. Here we go. Yeah, good. So you can see here, I've got a touch screen here. If I just move my finger out the way here, you can just about see. Touch screen. If I press on the different buttons here, you can see that this works just fine with touch. Now, Calc actually doesn't know anything about touch at all. Windows 7 is sending it a message, asking it a question, going, do you support touch? Now, Calc doesn't even understand the question, let alone the answer. So it doesn't answer that question. Windows 7 goes, okay, so you don't support touch. What I'll do for you is I will take all of the touch input. So Windows 7 is managing the touch input, takes all of the touch input, and it translates it into mouse input, which is something that the application does understand. Your Windows Forms applications and your WPF applications, if you have not employed any kind of touch code in it whatsoever, behave like this. They already work with touch right now. They do that by converting a finger into a mouse. It's single touch, but you get that for free. You don't have to do anything. It already works right now. Yeah, that's under the category of good. Yeah, it's somewhat limited here. If I bring down the menu, you'll see what the problem is here. So this menu is designed for a mouse. Now, I've been filing down my fingers for the last few months here, and I've got them into a very sharp point. So I've done this demo a number of times, and sadly, I actually get this demo right almost every time now. Yep. No, see, I got it wrong at last. There we go. I'm not deliberately getting it wrong here. Yes, so this user interface works, but you've got to have really pointy fingers to make this work. It was designed for use with a mouse, where you can go point at that very fine little thing. You can point on, like these radio buttons down the bottom here, you can point very easily. Now, I've got big, fat hands. I mean, they're not enormously fat, but where am I going? They're not designed to poke at these little radio buttons here. So, eventually I got it right. So this is the concept of good. Everyone okay? Oh, I meant to say before we start, which is a bit late now, I'm not very good at doing questions at the end of the presentation. And I don't like doing it anyway, because when you ask the question, it's out of context. It was like, about that thing that you were talking about at the beginning of the presentation. It's way out of context at that point. So if you have a question, please ask it during the presentation. Come up to the mic, so I won't see you if you raise your hands. And ask then, and then at the end of the presentation, I probably just stop and we leave and we go. There's no questions then. Okay. All right, so let's get rid of this one. Let me just put it back to standard where I can see it. Yeah, all right. So let's move on and see a concept of paint. So a concept of better. So good. So, and again, I find this kind of bizarre because we're looking at MS Paint, and I'm using that as a concept of better. I think that's probably a first, to be honest. So, again, we can see here that if I click on one of these different colors, kind of with my finger, and then I draw a line, then it's doing kind of what we did before. Yeah, you can't quite see the left-hand side there, but there we go. It's kind of doing what we did before. This is converting my touch input to a mouse input. And you go, that's not really that much different there. Where this is different is, actually, I'm not sure you can, sorry, let me try it this way around. Yeah, you can just about see it this way around. Okay, that's different. That's not converting converting touch to mouse. That was understanding, that was 3 simultaneous inputs. So MS Paint actually does understand touch. It understands multi-touch. Apart from that, it doesn't. It's designed for use with a mouse. Now, I'm not sure if I can show this from where I am. Yeah, let's try it. Nope. I'll tell you what. So we're just going to flick back here so that I can reach the bit that I'm trying to reach here. I realize you can't see my fingers at this point, but just trust me that I'm not using the mouse. So it's designed for use with a mouse. So if I select these things here, you can see all the controls are mouse-sized controls, not finger-sized controls. So if I select rulers here, I said that I've kind of sharpened my fingers down, and that's how come I can do this demo, but it actually is quite tough. I've been practicing this a lot. So the UI is not designed for this purpose. It is possible to use it. It's very fiddly, though. Okay, so that was the concept of better, which means it understands to some extent concept of multi-touch. All right, so let's move on to the concept of best. If I scroll down here and have a look at, there we go, have a look at Surface Collage. Surface Collage, standard application that comes with, there we go, comes with multi-touch applications, comes with Surface. And you can see here that I can pick these things up and move them around. It understands multi-touch because I can do a pinch and zoom gesture here, and we can do rotate, and we can throw things away, and I can manipulate multiple pictures simultaneously. Just about see my fingers there. It's also kind of nice because you can flick, and that one's actually, you can't see that one anymore. And I can flick, and they do have some kind of, I don't know if you noticed, there was inertia there. It bounced against the side and came back again. And it's full multi-touch. Now imagine that you had a mouse and you attempted to do that gesture with a mouse. How do you do that with a mouse? That's not an easy gesture to do with a mouse. So this is clearly designed for multi-touch and only multi-touch. Okay, and again, I'm going to have to flick back here because I actually need to see my screen to do this. Okay, last one I want to do before we start actually writing some of our own code. There we go, and there we go. And I'm going to get you to trust me for this one. I won't flick over the projector at all. Oh, why did that not work? So what we're looking at here is something called Surface Lagoon. This is a multi-touch application. It's also called an attract application. You can put it on the Surface device. And the point of this application is to attract people to your Microsoft Surface table, because it's nice to look at, and you go up to it, and you start doing things, and it's got an interactive surface. There's an interaction to this. Now this is kind of slightly interesting. If I put my finger down there, you can see all the ripples that go away, and eventually the fish are curious and they come back and they start to nibble at my, actually only one of them comes back, and they start to, oh, they've gone, okay, they're not coming. They start to nibble at my finger, and then I go like that and I scare them all away, and it amuses me. The difference between this application and the last one is the same difference between this and probably every other computing application you've ever seen or used. This one doesn't have a top. There's no top, there's no bottom. There are sides. That's important because when you move to a Surface device, there is no top. It's a table. It's a table. There are 4 sides on your table. There is no top, there is no bottom. There's only a top and a bottom on your computer monitor. And that's an important concept if we move to a Surface device. Okay, let's move on then. Right, so where were we? We were doing this and this and this. All right, so the applications that I was showing there came from Microsoft Touch Pack for Windows 7, which you used to have to sell your own grandmother to get, which was a pretty tough thing. I did sell my grandmother. She's currently in some basement in Seattle. She's fine, though. Sends her postcards and things. Unfortunately, you can get it for free now. I haven't told my grandmother that, but you can get it for free. You get it free with any multi-touch laptop, and you can download it. It's got a nice load of applications there which help you explore multi-touch. If you don't have a multi-touch device, then you can see a video of all the different applications and get some ideas for what you're going to do. Here's what you need to get started with multi-touch. You need either a multi-touch laptop like the one that I'm using over here, or a desktop with a multi-touch monitor, or alternatively, a regular laptop or a regular desktop. And I'll come back to that point in just a moment. You need Windows 7. This won't work with Windows Vista. You do need Windows 7 because that's where all the multi-touch technology is. You'll need Visual Studio 2010, and you will optionally need the Surface Toolkit for Windows Touch and the Surface SDK. And when I say optionally, I don't mean optionally at all. I mean you will need it. And I hope to prove that point over the next hour. Why do we absolutely need this? So if you don't have a touch device, you could simulate it with multi-touch Vista, which works really well on Windows 7. And the way it works is you take 2 mice and you plug them into your laptop via whatever means you have for plugging 2 mice into your laptop, and they become your 2 fingers. So you take your 2 mice and you move them around like this on 2 sides of the table, and it works as well as it sounds. Yeah, so you can do that just for trying it out today, and you think, yeah, okay, let's get this up and running today. If you can develop software for this, please don't do that. It's really not going to work. So let's have a look at the Manipulation API. Manipulation API, high-level API in WPF, which encapsulates all kinds of powerful behavior for multi-touch applications. So here I have Visual Studio 2010. I'm going to create a WPF application. Nothing special about it at all. WPF application. And we'll just change a few things here and there. Let's just change my height to be 600. We'll change the width to be, we'll call it 800. I'm going to change my grid so that it is a, so that it is a canvas, and it's got a name imaginatively canvas 1. Canvas 1. In my canvas, let's just change this bit here. In my canvas, I'm going to put a border that I will be able to move around with my fingers. There's a border. It's going to have a width of 300. It will have a height of 300. I'll give it a name. Let's give it a name. And again, I'm just not creative at all. We'll call it border 1. I'll give it a background, which will be blue. And there we go. That's my application. I admit, sad and tragic, but it's just a demo. I'm trying to do the fewest number of lines of code which show how this is going to work. Now, we've already seen that in that concept of good, that this will take touch input and convert it to mouse input. I actually want to use the manipulation API. So we have a property here. There's a property which says, is manipulation enabled? By default, it isn't. I'm going to set it to true. From here on, we will receive manipulation events. And that's where it will take all of the touch input, aggregate it up, and these events will now fire. Top of the list here is we get a manipulation delta event. Delta means change, so this event gets fired when a change has occurred, a manipulation change has occurred. So let's take our default there, and I'm going to scroll down here, and here's a piece of code I prepared earlier. Now at the moment, I'm just going to paste in some goo. Okay, I'm going to look at those lines of code. We are coming back to those lines of code. For the moment, just trust me. I know that sounds crazy, but really, just trust me. Now I'm going to add in another event down here, a manipulation starting event, and we'll put in a line of code here, down the bottom. And without particularly explaining what's going on here, I'm going to set a manipulation container to be canvas1. Let me just run this, and I can show you what we've got with a bunch of code that I admit full well we have not really explored. So here's my code, here's my application. I take my one finger, put it down on this border, and you can see I have a transform operation. I can move this around with my finger using the manipulation API. That was with a handful of lines of code, which I admit we haven't seen yet. But it was like a small amount of code. We've got touch support. Okay, let's look at our small amount of code then. Okay, so this manipulation delta event fires. And the first thing I'm going to do here is I'm going to take a matrix from my border. The matrix is the physical structure which contains the border. So it is a logical representation of the border. It's the bounds of this border. So I take the existing matrix, and then I'm going to translate the matrix. Translate is graphics speak for move. So I take my container, and I'm going to move it. I'm going to move it by this piece of information here. You can see that. We get passed in a manipulation delta event args. This is a package saying, this is the change which has occurred since the last time I called you. And it packages up all the things which have happened. It says, there you go, that's what happened, and you can do something with it. So what I'm going to do with that manipulation, with that delta manipulation, that's that one, sorry, the event args here, is we have a property called delta manipulation, which is the change which has occurred, and it has a property called translation. It says, you have moved to this coordinate, x, and you have moved to this y coordinate. And I'm simply going to move our matrix to those coordinates. And I end by saying, okay, having moved the matrix, I will now assign this new position back to the border, and we're good. That was it. Everyone okay? Still with me? All right, cool. Oh, and the only other change down here was I did my manipulation starting event here, which says, where are the coordinates relative to? I'm going to say they are relative to the canvas. Otherwise, we get an extremely unpleasant experience of where it calculates the coordinates incorrectly. Okay, so next thing I want to do is I want to scale. There we go. I want to scale my border. So if I run it, again, I haven't shown the code here, and we can see what happens here. I take my border, which we know I can move around here. If I take my two fingers, now I can move and scale my border simultaneously. Okay, so I pasted in a bunch of code there. Let's have a look at my code. That was the 3 lines of code that I pasted in. What I'm doing here with these lines here is I'm taking a point on the screen around which I want to perform my scaling. So as I put my 2 fingers down on the border, I want to start my scale operation but at the point in between my 2 fingers. So I want to scale in between, from the point in between those two fingers. That's what I'm doing there. I'm creating a point in between the two fingers that get put down there. And then I want to perform a scale operation. Well, the matrix already has a method called scale at, which allows us to scale that border. All I'm doing is I'm taking the information from the delta manipulation. That's this information here. Remember, we had an event args, which has a delta manipulation, and it has a property called scale. I'm saying scale the border by the amount that the manipulation API has told me we have scaled. I'm just passing that information on to the scale at method. Okay, so what we've got here is we've got transform, we've got scale. Let's take, oh, I don't want that. I want one more piece of code here. Okay, so we've also got rotate at. So we've seen scale. I get in my delta manipulation, I get a rotation saying you have rotated this much. And I simply, once again, pass that on to the rotate. And actually, I won't swatch the screen again, but that is so difficult to break the habit from. I now think that all screens are multi-touch. So as I do my scale before and my rotate, I do scale and rotate. And what was that? Something like 10 lines of code? That just cost me nothing to do that. That was very easy. Okay, what we might want to do next is, do you remember I was using the surface collage, and I would take these pictures and I would flick them away, and they would go off as I flick them. They had inertia. Let me add inertia to my border. So let's add in an event here. The manipulation API detects the flick gesture. As I flick with my finger, the manipulation API detects that gesture and calls me back. And it says, okay, at this point, I'm going to give you a hook here to say, I have detected that inertia is starting. Would you like to do something about this event? So what I'm going to do here is, in my manipulation and inertia starting event, we get the fantastically named manipulation inertia starting event args. And we can say what we want to happen at the point that we have detected inertia. So I'm going to say, take the translation behavior and set a desired deceleration for it. Now, the unit of movement of my finger is a squared millisecond. Now, we're used to speed being something like miles per hour. It's measured as you move your finger across the screen. It's a squared millisecond. So what I'm saying here is I want you to decrease your speed by 0.001 squared milliseconds. And I could, if I wanted to, also apply this to the rotation behavior. I think for completeness sake, we will just do that. Okay, let me run it again. And what I can do here is if I put my finger on this border and flick, you can see it moves. It has inertia. So actually, we can see a few more things here as I flick it. I just flick it a bit, flick it a little bit more. And it's gone. You go, oh, okay, let's just pull it up to full screen there. And it's gone. It's in the next room there, watching SharePoint. It's down the street. It's gone through Atlanta. It's in the Atlantic Ocean. I don't know where it's gone, but it's not coming back. In fact, just click on that one there. Yeah, so it has stopped somewhere, obviously. But at no point did I give it any code, which will say, and at the edge of the screen, you ought to stop. That would be a good place to stop, because in terms of user experience, this would be considered a poor user experience, whether you go flick, goodbye, goodbye, bye-bye. So that's not a good user experience. Let me explain what's going on there in order to solve this problem. The manipulation API, called our manipulation delta event every single time it aggregated a change. As I moved my finger across the screen, it aggregated, oh, you have moved from this point to that point. Actually, it called us maybe many times in between there, but it takes up an aggregation of all the changes which have been discovered and then passes it on to you. When it detects the flick gesture, something slightly different happens. It says, okay, at this point, and I'm going to switch units here, okay? The units are actually squared milliseconds. I'm going to switch to miles per hour just so that we've got somewhere to understand how this works. As you do the flick gesture and you say, right, at that point we were doing 100 miles, the border was doing 100 miles an hour, it will then go, okay, you've taken your finger off. I'm still going to call the manipulation delta event. And I'm going to say, I'm calling you with 100 miles per hour. Now I'm going to check my inertia starting, and I go, okay, you want to decrease by this much. I'm now going to call you back again at 90 miles an hour, and again at 80 miles an hour. I'm going to keep doing that until I've decreased the speed down to 0. Then I'm going to stop calling you. So we want to hook into that process and say, okay, well, actually, I've got another point at which you might want to stop calling me back. So let's paste this piece of code in here. And this piece of code, let me just reformat it slightly. Okay, so this piece of code says if is inertial. When we get called back, we get a little flag which says, am I calling you because of a touch event, or am I calling you because of an inertia event? We're saying, okay, we're being called back here because this is inertia. So I'm going to create a rectangle for the canvas. On the next line, I'm going to create a rectangle which is the bounds of the border. My check here is really simple. It says, does the canvas rectangle completely contain the border rectangle? If it does not completely contain the border rectangle, stop. And if I run this, you will see that when I do the flick gesture on this, and it comes across to the edge of the screen, it stops. It's like it hit a bunch of sand and it just stopped at that point dead. And that is the manipulation API. I'm expecting, as an exercise for you, what you can do here is you say, well, as I hit the bounds of the canvas, surely I would want to bounce back. You need nothing from me to solve that problem. You've learnt everything that you need to know about the manipulation API to go, okay, so I've hit the bounds here. I need to actually start decelerating in the opposite direction. You can do that right now. It's just code, just C# code. All right, I'm going to move on to a new subject here. Before I do, questions, anyone? Okay, so I think the question there is, what's the best practice for when you have multiple controls, and how would you manage the different events going to different controls? Actually, the controls themselves have their own events. So the manipulation API says, so you have a transform here, and this other control here has a scale app. It will call the manipulation API will call those events on those different controls independently, and because you should not be sharing those events under that circumstance, you get your own event.
Yeah, I was wondering though, can an event of the first control trigger event on the subsequent, so they all move as units? So if you had 3 blue.
Oh, I see. Yes, absolutely. Yes, if you want to grab hold of one border and you have 2 other borders which are arranged in a nice fashion next to them, yes, you could just add the code to the method that I have created. Yes, absolutely. You could treat them together. Yep. Okay, let's move on then. We'll go back to the slides for a moment. Let me just get rid of that one there. And good. Okay, so let's move on to the raw touch API. And the raw touch API looks like the mouse API. On the left-hand side of the screen, we are looking at a bunch of touch events that you can get from the raw touch API, which is not mutually exclusive with the manipulation API. They can be used in combination together. On the right-hand side, we're looking at mouse events. If you are familiar with programming mouse control, you are already familiar with, with programming touch support using the raw touch API. You can see on the left-hand side we have an event called touchdown, which would be equivalent to the mouse down event, and preview touchdown, preview mouse down, touch move and mouse move, and the touch up event, which just is begging me to do some innuendo joke along the lines of Benny Hill, and I just can't bring I know that you think I'm British and we love Benny Hill, but we don't. So I can't do it. I can't bring it's pathetic and puerile. So, but anyway, so for every mouse event which you are used to, there is an equivalent touch event. So let's see how that works then. Let's go here. So here's a very simple application that I've written here. This is just it's going to explore the different touch events. I appreciate that my color scheming is sad and tragic, and that's just the way it is. So we've got a canvas here which has a touch down, touch move, and touch up event. And I've hooked into those, and we'll have a look at one of those in a moment. I also have a rectangle here, which is the yellow bit, which has a touch down, touch move, and touch up event. But just very briefly have a look at the, I don't want to do that. Very briefly have a look at the code behind here. There's the canvas touch down event. I have got a list of touch event objects. I'm just going to add a canvas touch down string to that event list, and then I've got a data grid somewhere, and I'm just going to do a refresh on it. Every single method looks like that. Okay, so let's just change that over there, move that slightly over here. Okay. Wow, that's come out. We'll go with that. Okay, so as I put my finger down and move it across the grid, which is now in a weird color, you see that it fires lots of different events, which I have put on a grid for us to see. It started off with the canvas touch down event as I put my finger down onto the screen. As I move slowly down here, you can see there's lots and lots of touch moves as I was moving my finger across the canvas. Slowly comes down to the bottom. I lift my finger off the canvas. We get a touch up event. That was simple. Okay. Now watch what happens when I move my finger across the canvas onto the rectangle and out of the canvas the other side. Okay, we get a bunch of events here, starting off with a canvas touch down, so I put my finger down. I then move to a canvas move as I'm moving my finger across. I then enter the rectangle, and I get lots of touch move events as I move across the rectangle. Now, you have a choice here. The way I've set this up is I've chosen not to bubble the events back up to the canvas. The rectangle is sitting on top of the canvas. If I wanted, I could have allowed the canvas to have received those events as well. And we keep moving down here through the rectangle, and then I move up. I move over onto the canvas, and eventually, although it's gone off the screen, I would have had a touch up event. Okay, so far, that's exactly what you get with a mouse. The difference with touch events is that they understand that there could be many of them for different fingers. I have many fingers on my hand here. In this example, what I'm going to do is I'm going to put 2 fingers down and move them across the surface. Okay, so I got a touchdown event. I got a touchdown event on the first finger, and I got a touchdown event on the second finger. Notice, because I have got 2 columns here, I have some way of working out that this finger is not the same as this finger. I can track these fingers independently of each other. It's thanks to the device, the touch device ID. This is given an ID, a number, just a number, and this is given a different ID, and I track them using that method. As I move them across the canvas here, you can see the first finger is moving, second finger is moving, and so on, and eventually they lift up off the page. Okay, so we've learnt a little bit about touch events there. Let me, if I can do that. Okay, so let me show another demo which Yeah, as we can't see all of the screen there, let me just flick back here. Here's a demo from a guy called Joshua Blake that I've modified for my purposes. This has got, I know you can't see my fingers here, but that's not actually the important point of this demo here. On this demo, I'm going to move my finger across the screen here. And you can see it's drawing a line across the screen, which we know we can get with, it's all done with the raw touch API. We can see that I could have got this information that I could draw the line across. A couple of things I want to point out here. Notice at the end of the line there, we have some text on the screen. We get passed in an event args for each one of the touch down, touch move, touch up events and all of the other events. We get an event args which has got a bunch of information in it. And this is the information which is displayed on the screen there. We get an action, which is your finger is moving. We get a position saying it is at this point, and when it's called back again, it's now at a different position. That's how come we can draw the line, because I'm tracing the position as each time we get called back and it's drawing a line across there. We get a size, and for me this is somewhat weird because this is the only device that I have run this on where the size is 0. I run it on other devices and you see a size in here. I don't know why that is. This is a new laptop for me. I'll find it out at some point. But what I would expect to see here, and I do on every other device, is I see a size. The size is what was the size of the touch device which was put on the screen. So if I use my little itty-bitty finger here, I get a very small size. If I use a big fat thumb, you get a very large size. The reason why that's important is because when this demo works on any other machine, you see a big blob drawn there. And the blob is drawn the size of whatever finger is put on there. You put the little itty-bitty finger down, you get a small blob. You put the thumb down, you get a big blob. That's called an aura. It's not. It's called an aura. The aura is visual feedback for what are you doing with the device at the moment. The other thing that you can see there is a device ID. So if I do this again and I put 3 fingers down, you can see there's a device ID on the top one of 24. The middle one is device ID 22. The bottom one is a device ID 23, which is how we can track these different fingers here. Now if I do this again and I do it with 5 fingers, you can see I get 5 trace points here. If I do it, and this one's slightly difficult here, but I might have to do this a couple of times. All right, nope, that's not what I need. Let's try that one again. You know, what is that? That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Okay, we'll go with 9. Unlike the members of the Simpson family, I've got 10 touch points right here. This hardware here supports 10 touch points, which kind of ruins my demo slightly, because what I wanted to show you here is what happens when you use more touch points than the device will support. I've only got 10 touch points without the aid of asking one of you guys up to come up here and help me. The limitation is not Windows 7. The limitation is not WPF. It's down to the hardware. The Windows 7 and WPF can cope with however many touch points you want to throw at it. There is a logical limit, but you're just not going to find enough people to hit that limit. Okay, last point I want to make on the raw touch API before we move on here is when we were doing the manipulation API, we got called back saying you have moved from this point to this point. And actually we were called many times. As I traced my finger along with the border, it would say I'm calling you here and here and here and here and here along the line. But it's still an aggregation of all the things which have happened. Think about the pinch gesture which I did on the border. The manipulation API aggregated all that information. It said, you have scaled by this much. Now consider, what would you need to write? What code would you need to write to achieve the same result with the raw touch API? A significant amount of code. You would need to track the 2 fingers independently of each other. You would need to recognize the pinch gesture. You'd need to recognize the flick gesture. You'd need to handle inertia. That's a significant amount of code, and I suggest that you don't write it. Okay, I'm going to move on then. Right. Let's get rid of that one. And let's just go back to the slide here. So we did that. Let's move on to the Surface Toolkit for Windows Touch. Now we've got a URL there which I can't imagine anyone's going to write down. The way that you find the Surface Toolkit for Windows Touch is you use a browser with your favorite search engine and you just search for it. That's the best way to find it. And you can download it. It's free. And it has a number of features. It includes replacement controls that understand multi-touch, and that's something I want to show right now. New controls, which are suitable for multi-touch, we will see that. Multi-touch is a new environment. We're not just limited to the mouse now, there are more possibilities, so we'll look at those. It also handles touch visualizations, by which I mean auras, trails, and tethers. We will look at those. It also handles a drag and drop framework. Drag and drop, when you have multiple touch devices, is not the same as drag and drop for a mouse. So, important point here, the Surface Toolkit is not available for Silverlight. In fact, I should have mentioned here, pretty much everything I'm talking about here is not available for Silverlight. Silverlight does have touch support, and Silverlight for Windows Phone 7 has a significantly improved support for multi-touch, but they are not the same as they're not as powerful by any stretch of the imagination as what we're doing here. So, let's talk about these replacements for traditional controls. On the left-hand side, you can see there's a set of WPF controls. On the right-hand side, we have the equivalent Surface control. What I'm saying here is that for each of the controls that you are used to using, there's an equivalent Surface version. You may think, do I actually need to do this? So let's take a quick look and see. So I've got a very Mickey Mouse program to start off with, and yeah, let's see if I can get this on the screen here. Yeah, that'll do. Okay, so this is an incredibly simplistic program here. On the left-hand side, I have some WPF buttons. 1, button 2. And you can see what they do. As I click on them, they add to a list box in the middle that this button has been clicked. And if I have some buttons on the right-hand side, which are Surface buttons, and if I touch those Surface buttons, you can see that they add to the list box. That's all that the buttons do. What I want to do with this demo here is illustrate the difference between the behavior of these different sets of controls. WPF on the left, Surface on the right. Watch what happens when I click on both button 1 and button 2 at the same time, the WPF buttons. Now, the nice thing about this demo is that you can actually see my fingers trying to click on these buttons at the same time. Every other time I've done this, I didn't have a camera on my finger, and I had to get everybody to trust me that I honestly was trying to press on these two buttons at the same time. And really, I am. Hopefully, the effect that you're seeing is one button gets clicked on or pressed on. One button only. Okay, let's do the same again with my Surface buttons. There's no trick here. I haven't just written funny code or something like that. Both Surface buttons are active simultaneously. They don't have a concept of excluding some other control. Why do we want this to happen? If you consider perhaps we're working, for a laptop here, that's not particularly useful. If we have, let's say, a line of business application, which I don't actually recommend, but let's say we've got a line of business application, you're looking at a customer, and you've got a button which says save and a button which says delete, and you click on both of them at the same time, that's not a useful thing to do. You actually don't want your users to be able to say, save the deleted customer. That's not helpful. Where it is helpful is we have a table device. You have a table device, you have more than one person. The people want to work in their own space. Let's say I'm on one side of the table, my son in my living room is on the other side of the table. I do not want him to block me from what I'm doing. I'm working on my stuff, he's working on his stuff. Maybe the same application, and if it's a game, then it will be, but I don't want him to block me and I don't want to block him. So we have a difference of behavior here. Something else I want to point out here is, watch what happens when I press the Tab key. As I'm pressing the Tab key, you can see I am moving through the different WPF buttons. At no point did I ever tab to the surface buttons. There's a reason for that. If you look at your hands, you do not have a tab key on your hands. If you do have a tab key, you really need to see a doctor, because that's not right. So there's no tab key here. It doesn't make any sense to do this. So you can see these controls behave differently. Okay? So let's keep looking at the difference between these controls here. I've laid out some controls so that we can see them, we can have a comparison slightly better, and I don't know why that's not coming up. Ah, there we go. Okay, good. All right, I think we can all see that. Good. Let's just make that slightly bigger.
Can I ask a question real quick on the buttons?
I'm sorry?
Is there a predefined order when you press both of them at the same time? That they come
No,
together?
there's no predefined order.
And then when you did it, it was always 2, 1, 2, 1, 2, 1.
Oh, that was probably just my inability to press buttons properly. So we're looking at the left-hand side, we're looking at WPF controls. On the right-hand side, I'm looking at equivalent surface controls. Clearly, there's a visual difference between these controls, which is largely irrelevant, because if you think about WPF, you can template your controls. You could change the visual appearance of WPF controls. That's not particularly the biggest deal here. But in its default form, let's, so used to doing that. So on its default form, I can press the checkbox and we get the desired result. As I press the surface checkbox, look what happens there. I don't know if you can just see, let me just do it again there. And there's this beautiful animation here. And I don't know about you, but every time I do this, in my head, I hear it go, wom. 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 I could do it, sorry, I could just do this for hours. Wom, wom. I hear voices too. Probably shouldn't have shared that. Okay, so there is a different visual appearance to these and a beautiful animation, which you might have got some other way. Let's look at the slider here. So the slider here in a somewhat tragic kind of WPF way, which we could have templated, so that's not like the end of the story here. This slider, slightly different. Let's have a look at this slider. Now, as I put my finger down there, notice there was a visual appearance to this. This is called an aura, which is visual feedback for where is my finger at this moment. And as I move it up and down, yeah, we can see here. We also get a few more animations of where my finger is and how it's dragging it and what the background is. But also notice, as I'm using the control, my finger may move off the control slightly as I'm not looking at what I'm doing. As I move my finger off the control, you should be able to see a kind of a ghostly line between my finger and the control which I am controlling. This is a tether. There's my tether there. Right, so Microsoft done a fair amount of research on this, and we're trying to use these controls using touch, which is supposed to be a natural interface. We have a problem here where the application is behaving logically, consistently, according to the rules of touch. But that might not be what the user was expecting to actually happen. They may have been rethinking something else would happen. There's an awful lot of research which has gone into this, and one of the bottom lines for this research is your users can understand what is happening much better if they can see what is happening. If they make a mistake and the user interface does not behave the way that they thought it would, even though it is logically correct, it's obeying the rules of touch, if they can see what's going on, they can understand what they did wrong and they can adapt their behavior better. So you give them visual feedback in the form of auras and tethers, and this thing here that you might be able to see, I don't know if you can see this, as I move my finger around here, you should be able to see a little trail behind my finger. So we get auras, trails, and tethers, visual feedback on what we're doing. Again, if we move on to the list box control here, and I put my finger down, you may look at this and go, that's a tiny little scroll bar. As I put my finger down, it goes, it's a big fat scroll bar. It's a finger-sized scroll bar as I move up and down here. And I get the same thing on the other scroll bar, on the left and right scroll bar. What's really interesting about this list box is it's multi-touch. Of course it's multi-touch. As soon as I press my finger in the right place, it will be multi-touch. Any second now. Why doesn't this work anymore? Okay. That's really weird. Why doesn't that? There we go. Okay, so the point that I was trying to make is, look, multi-touch. I should be able to use both scroll bars at the same time because I have two fingers. I have many fingers in which to do this. You cannot do this with this control. It doesn't understand that concept. Finally, we have an ink canvas down here. That's the WPF one, and I don't know if I can do it on this one here. No, I can't do it on this one here because I don't have enough space for it. Nope, I don't have enough space for it. Okay, that's not working. I don't know why. I should be able to do multi-touch on the ink canvas there and draw many lines at the same time. So the surface controls are adapted to understanding that you could do multiple things at the same time. So I said I'd also talk about additional controls which are available in the Surface Toolkit. Here's the Surface Library controls, and we've got this is a library stack. If I tap it, you can see I'm moving things to the back of the stack. This is effectively a list box. It's a list box, an ordered list box, in which we can use touch to manipulate the order. I have a library bar here. Again, something like a equivalent to a list box, but it's a reimagining of a list box for touch. It's got this kind of springy thing that goes on here. And it's got a springy thing that goes on here. What's interesting about these controls is they understand drag and drop. So if I can take this one here and drop it over here, we get drag and drop, but it's multi-touch. So I should be able to, when I get it right, I should be able to drag and drop anything to anything simultaneously, which you can't do with the mouse API because it doesn't understand that concept. So we have reimagining of controls which are much better suited to multi-touch. Okay. Right, let's go back to the slides then and see what we've got here. Yeah, actually, just before we do that, one last demo here. Okay, so we saw the Surface collage application right at the beginning of the presentation. When you install the Surface Toolkit, you get a new tab here, which is for Surface, and we get Windows Touch. You can see here we've got a WPF application, which is for Surface. It's a WPF application, but instead of using WPF controls, it's using Surface controls. Let's create one of these and see what we get out of this. Yeah, you can see that. Okay, good. And let's just change that. Okay, so I'm going to add to this. There we go. Let's add to this a scatter view control. There's my scatter view control. And my scatter view control has scatter, when I type it properly, has scatter view items. And my scatter view item, I'm just going to put one item in there. This scatter view item is going to contain a view box. And I think we might stick in a height of 300 and a width of 300. Okay, so we saw the Surface collage. What you should be able to see here is, here's effectively a border. This border allows me to transform it, allows me to scale it, allows me to rotate it, it allows me to flick it, and it bounces off the side. Hey, how about that? It has, as I'm moving it around, you should be able to see there is a border, there's a shadow behind it, behind the direction in which I'm moving. If you are able to see, it's not sure if you can see it from that control there, you can see there's an aura for my finger. There should also be a trail for my finger as well. I get all that from 5 lines of XAML. So, we started this by looking at the manipulation API. We saw that we got a really good result from writing, 10, 15 lines of code, which you don't need to write if you use the Surface Toolkit, where all of the concepts, the drag-drop framework, auras, trails, tethers, the concept of having a multi-touch application is built in. So what I'd like you to take away from that particular point is, when you're thinking about your applications, maybe you have a line of business application where your boss has said, could we just make this multi-touch? I am hoping that you have learnt over all the things I've done here that that's perhaps not a great idea, because there is no happy medium between saying this is a mouse application and it is also a touch application as well. If you design for touch, it will look and it will behave differently. You could still use it as a mouse application in the same way that you could use a mouse application for single touch. It just won't look right. Okay, some resources I'd like to share with you. There is a fantastic book here called Natural User Interfaces in .NET by Joshua Blake. This is in early access program at the moment. It will be out in summer 2011. It is a great book. He writes with enormous authority on this subject. No, I don't have shares in this book. Really wish I did, though. It's a brilliant book. It's really well written, and the amount of depth in this book is really considerable. It's a very authoritative read. There's another book here by Dr. Neil Rudin, who's also an expert on Surface. This is wholly about Surface, not about WPF. It's written for Surface 1. The top book is for Surface 1, and actually, I think it's been updated for Surface 2. Yes, it is. Dr. Neil Rudin's book is available as an ebook. It's for Surface 1 at the moment. You can get it as a paper book from lulu.com. And I have no doubt that will get eventually updated for Surface 2. There's a bunch of training videos which are free at this particular location here by a guy called Chris Athy. This is about how do you get started with Microsoft Surface 1 development. These are going to be updated for Surface 2 shortly. So, I want to talk about Microsoft Surface 2 for a moment. This is not Microsoft Surface 2. This is Microsoft Surface 1. And although when I first saw this, I thought, this is fantastic. This is a wonderful device here. It's kind of iconic now, and dare I say it, somewhat clunky now. I don't know if you ever had a chance to look at these, but there are several pieces involved in this little picture here. Right at the top, we have a translucent surface, which is a multi-touch surface. So there's multi-touch in there, but you can notice straight away there is a great big box underneath it. Huge box underneath it. This thing weighs 198 pounds. So 66 kilos. Takes 5 people to lift it. And it needs to be carried in a very special way. It goes inside a truck and is encased in a special container to move these devices around. What's in the box there is a Windows Vista computer armed with 5 cameras. 5 cameras which are pointed up at the translucent surface at the top there. The surface itself supports 52 touch points. That will be enough for 5 people using every digit they've got with 2 left over. That's a lot of people. You stick that in your living room and you've got 5 people around it going, no, it's my turn. No, it's everybody's turn. Or at least it's 5 people's turn. That's a great piece of kit. Retails at, depending upon where you live and various different deals, somewhere around $15,000 US. So it's not a piece of kit you're going to buy quickly. So here is a Surface 2 device. Now, there are a few things to notice here. First one is, wow, what a beautiful piece of kit. Now that's a nice piece of kit. That other one, that was ugly, and that's yesterday's technology. This one's beautiful. Is that not? That's something you'd have in your living room. That's a nice piece of kit there. The other thing that's interesting about this is, where's the box underneath? The reason why they've got those 5 cameras in the Surface 1 device is they do depth recognition. They're not just looking at your fingers moving around. They do all kinds of things like a recognition of different devices placed on top. But they also do depth recognition. You take a bottle of water here. Take a bottle of water and put it on your Surface 1 table. It doesn't say that's a circle as it looks at the bottom of the bottle. It says that's a tube which has this much water in it. If I drink the water out of it and put it back down, it'll go, that's a tube which is empty. It has depth recognition in it. It uses the 5 cameras to achieve that. Now we look at this and go, okay, so it looks nicer. You can actually put your legs under the table. Great concept for a table. But how's it doing that camera thing with the depth recognition? Where do those cameras go? And this is the coolest idea ever. I'm just so pleased about this. Microsoft have got a name for everything, of course. They call this Pixel Sense. Ignoring the name for a moment, they've taken every pixel of the monitor and put a camera in every pixel. Holy cow. That's clever. Is that not clever? I think that's exceptionally clever. That's how they're getting their depth. That's how, this is 4 inches thick. It weighs 30 kilos, not 66 kilos, 30 kilos. And, oh, the legs are detachable as well. What's interesting about the legs being detachable is you take off the legs, you hang it up on your wall. Now you've got lots of people walking around going, okay, let's do some brainstorming here. You'd put that in your boardroom, and that would work in your boardroom. You take a Surface 1 and put it on the wall, it will fall off. And half the wall will come with it too. So that's not a good thing. So there you go. 4 inches thick using Pixel Sense. It runs Windows 7. It's just, in that respect, fairly ordinary technology. The Surface 2 SDK will be released later this year. No specific date on that. This particular device is a Samsung SUR 40. It costs, and the price, I don't know, it is somewhere between $7,200 and $7,600 US, depending upon how they finish their pricing. You can't buy it right now, but that is the expected pricing. So here's the, apart from the fact that this is just a great thing to talk about anyway, here's the thing that I want you to think about on this. Surface 1 came out 3 years ago, $15,000 US. Surface 2 will be out this year sometime, in the order of $7,500 US. Took 3 years to halve the price and to halve the weight and to make it portable and to make it beautiful. How long will it take before it's sub 1,000 US? 3 years? Where do you want to be? When, at the point that it comes into your home and it's in the kitchen and it's in the living room, there are no apps which are dealing with the management of your family in an effective way at this point. When it goes into your living room and it goes into your kitchen, now we're talking about management of your lifestyle. And obviously that will then turn up on your iPhone and your Windows Phone 7 and all the other devices that you've got. But it changes the way that you will use your computer, and it will become a family event. You want to be writing those applications now so that you beat the curve, because that's coming. It is a matter of time. I'll come back. It is a matter of time before we get there. It's not if. So we were talking about extra controls and re-envisaging our world. There are a couple of, there's a number of Surface 2 controls which will be free as soon as the SDK is released from InfoStat. I wanted to mention them so that you're aware that these controls are free. There's Deep Zoom, PowerPoint Viewer, Pivot Viewer, Physics Canvas, and no, I don't have any shares in InfoStat, although I am thinking about it now. If you don't have these controls, watch a video at that particular location. So here's what I want you to take from this presentation. If you don't do anything at all, take your existing Windows Forms and WPF applications right now. They will work with touch. It's just the touch event is promoted to a mouse event. They won't look like touch applications, but they will work. There are 2 touch APIs out there. There's the manipulation API, which we saw was very high level and was aggregating all kinds of movement with fingers and changes and everything. And it just takes an aggregation of here are all the changes that we've discovered and just fires you, there's your changes, go do something with it. And that's a really powerful feature. There is the raw touch API, again, a Spider-Man API. Great power comes great responsibility, and it's all your own work. You could do everything, absolutely. You could recognize new gestures, which is not a small piece of work, really. So for example, you want to recognize the infinity gesture. So you take your finger, you trace an infinity symbol. That's a simple enough gesture. What is the maths to do that? It's quite considerable. So you have two APIs. You also have the Surface Toolkit, which I suggest, if you're writing a touch application, you write the vast majority of your application using the Surface Toolkit. It provides you with all kinds of infrastructure that make your application look like a multi-touch application. You use the other two APIs for writing your own controls to achieve things that Surface doesn't currently do. And, okay, and I think we are done. Okay, there was a question somewhere at the back. Yeah, do you want to come up to the microphone?
Could the table also recognize the identity of the hands, or who is actually putting the hand up?
Oh, no. Actually, with Surface, yes.
Yeah.
With Surface, you could do that because you get a camera image of what's actually what's actually touching the table. So you get a camera image of that. For Surface 1, that's black and white, if I remember correctly. For Surface 2, I don't know.
So if you could play games or not, depending on the ID, I don't know if that's the direction.
Oh, you want to do fingerprint recognition? Is that
Or
it?
somehow, how would you figure out if 4 people are playing a game, who is doing what?
Ah, okay. The granularity is not good enough to do fingerprint recognition. That's very interesting. You want to ID the person based upon their hands?
Well, if there's a table, there's probably different people around the table.
Yeah.
So where is the gestures coming from?
You can recognize that those hands belong to person number 1, but not John as opposed to Susan.
Right. Even that, if I were to put my hand a little bit closer to the other person, how would they know it's number 1 or 2?
So so for the Raw Touch API, for example, if I put my hand over here, then that's 5 different touch points, and they are not related to my 5 different touch points over here at all. You could only do that based upon proximity.
So if here's my 2 hands, and another person puts their hand right here.
And there is no way of knowing that that wasn't
Okay.
your hand. There was no way of knowing you don't have 3 hands.
Yeah.
So, no. Only with Surface could you do some sort of camera recognition and try to work that out, but not with WPF. There's no way to do that. Okay, so I reckon that's it. I will take questions after the presentation. Do come up to the front and ask me. I hope you found this session useful. Hope you're enjoying TechEd, and I hope to see you next year. Thank you very much.